Hi, let us go through the complete worksheet of the problems that you did as a test. So the first question is, relative density of an object is 1.35. Will it float or sink in water? So since the relative density is 1.35, so the relative density is greater than 1. So if relative density is greater than 1, it will sink in water. Let's go to the next question. An object is put one by one in three liquids having different densities. So let us take three liquids and let's take an object which is put in one, and then we would take the same thing and put it into the next one and into the next one. So when I put it into the first one, I find that 1 by 9 part of it is outside the surface, outside the liquid surface. And here you have 2 by 9 part out, and you have 3 by 7 part out. So the first thing to do is to make the denominator same so that we understand which one has more volume outside. So if I take the LCMs, I can find out that the volume 1 here is 77 by 693. If you are wondering how I got this, the LCM is, this is 9 2 by 11. So it is 9 into 11 into 7, and in the first case it would be 11 into 7. So if I do that, I would get 77 by 693. Similarly, V2, if you follow the same process, I would end up with 126 by 693, and V3 equals 297 by 693. So basically this clearly shows that in the first case the volume of this which is outside is less than the volume that is outside here in the second case, which is less than the volume in the third case. So in the third case you'll find that the maximum volume is outside. So if the maximum volume has to be outside, then that means that there is a lot of upthrust in the third case. So the upthrust is more, that would mean that the density is more. So from that I can easily say that D1 is less than D2 and D1 is less than D2 and D2 is less than D3. So I have arranged them in ascending order. I hope you understood this one. Now let's go to the third one. An object weighs 10 Newton in air. When fully immersed in water, it weighs 8 Newton. Find the weight of the liquid displaced by the object. So weight of liquid displaced is equal to the apparent loss of weight. Displaced is equal to apparent loss of weight. So the loss of weight in this case is 10 Newton minus 8 Newton, which is equal to 2 Newton. So 2 Newton is the weight of liquid displaced by the object. Next one, relate the SI unit of density with its CGS unit. The SI unit of density, the SI unit is in kilogram per meter cube. If I were to convert the kilogram per meter cube to centimeter, that is to gram per centimeter cube, which is the CGS unit. Then kilogram, 1 kilogram would be 1000 gram, and meter cube, 1 meter is equal to 100 centimeters. So 100 cube centimeter cube, which is nothing but 1000 by 1, 2, 3, 4, 5, 6 zeros, which goes per centimeter cube, or 0.0001 gram per centimeter cube. The next question. The relative density of silver is 10.8. Density of water is 1000 kilogram per meter cube. What is the density of silver in SI units? The relative density of any substance is equal to the density of the substance by density of water. So substituting the values that we have here, we get 10.8 equals density of silver by density of water, which is 1000, or I would say the density of silver, rho Ag. If I were to represent this as rho Ag, so 10.8 into 1000 is equal to 1.08 into 10 power 4 kilogram per meter cube, because the answer is needed in SI units. The next question. State two factors on which the magnitude of the buoyant force acting on a body immersed in a fluid depends. We know that buoyant force is equal to the weight of liquid displaced, and that weight of the liquid displaced is equal to, depends on the volume of body immersed. That much water is displaced, so volume of the body immersed. How much how much ever, suppose if there is a fluid, I immerse a body, and this volume, the volume of this much, the part that is immersed into density of water. So volume of body immersed will be the equal to the is equal to the volume of the water that is displaced and into the density of the water. So the two factors would be volume of the body, and second is density of the fluid. It would be better to talk in terms of fluid, since in the question we have fluid over here. Then next question. At what speed a body of mass 1 kg will have a kinetic energy of 1 joule? So kinetic energy, as all of us know, is half mv squared. This is the formula. So kinetic energy is 1 joule, it is given, that is equal to half into the mass is also given, 1 into v square. So v square is equal to 2. So v is equal to root 2 meter per second. Next, a 2-meter high person, it must be quite a giant. So he is holding a 25 kg trunk on his head. So he is holding it. This is 25 kg and standing at a bus stop. How much work is done by the person? We all know work is equal to force into displacement. So here the force exerted on the object. So on this particular object, the man is exerting maybe exerting a force to keep it up in the air, but there is no displacement. It doesn't come down or it doesn't go up further. So therefore, totally there is no displacement. So it is F into 0. Therefore, the work done by the person would be 0. Calculate the work done required to stop a car of 1500 kg. So we have this car which is moving at a velocity of 60 km per hour. So the kinetic energy of this body is half into m into v square. This is equal to half into 1500 into v square is 60 into it is given here in kilometer per hour. We need to convert it into meter per second. 60 into 5 by 18 whole squared. So this would be the kinetic energy of the body at that instant. So if you need to stop it, so much work has to be done that has to be equal to the kinetic energy to stop it. So basically the work done would be equal to the kinetic energy. So the calculation, if we were to do the calculation further, the final answer would be 20.83 into 10 to the power 4 joules. List two conditions needed which needs to be satisfied. Conditions which need to be satisfied for work to be done on an object. So work to be done on an object, there has to be a force acting on the object and there has to be a displacement of the object. So if both these things, both these factors or both these conditions are satisfied, then you have work done on an object. The next question. A force of 10 Newton acts on a body of 2 kg for 3 seconds. So I have a mass of body is 2 kg and there is a force acting on this body which is 10 Newton and the time of 3 seconds for which it is acting. So if I have force and a mass and I can be because of this. So acceleration is equal to F by m, which is 10 by 2, which is equal to 5 meter per second squared. Now I have acceleration. So if a body was initially at rest and for 3 seconds it was acted upon by this force, so you can take u, initial velocity is equal to 0, and v is equal to u plus a t from the equations of motion. This is the first equation of motion, and then here we have u is 0, the a would be 5 which we have found out, and time is 3 seconds, so that would be 15 meter per second. So 15 meter per second. And now the kinetic energy, so at the end of and the third second the velocity is 15 meter per second, so the kinetic energy, the formula is half into mv squared. So mass is 2, so half into 2 into 15 square, which is nothing but 225 joules, because 2 goes and 15 square is 225. The next question. An electric bulb of 60 watt is used for 6 hours per day. Calculate the units of energy consumed in 1 day by the bulb. So energy is equal to power into time. The power here is 60 watt and the time is 6 hours per day. they are asking to calculate the units of energy consumed in 1 day by the bulb. So in 1 day, 6 hours is the time that the bulb is used. So the power is 60 into time of 6 hours. So it is 6 into 6, 36, 360 watt hour, because the power is in watts and time is in hour. But the question asked is units of energy. So unit of energy, 1 unit of energy is normally 1 kilowatt hour. So this needs to be converted into kilowatt hour. So 360, the watts should be converted to kilowatt. So 360, here it would be 60 by 1000, or I'm doing it now at this stage. So 360 by 1000, or 0.36 kilowatt hour, or I can write it as 0.36 units. The next question, 16 bulbs of 40 watts. So the power 40 watt is used for 6 hours a day, along with one bulb of 100 watt for 2 hours. So if I see here, the energy, power into time, which is equal to 40 by, we want to change it to kilowatt. So 40 by 1000 into 6. Here it would be, and there are 16 bulbs, so this whole thing into 16, and here it is again P into T. So 100 by 1000 into 2 into 1. So if I were to add up the whole thing, I will get 3. So it is 3840 by 1000, and here it would be 200 by 1000. So I get 3.84 plus 0.2, which is 4.04 kilowatt hour, or I can write it as 4.04 units. One unit is a commercial unit. It is a commercial unit of electricity, and a commercial unit of electricity is 1 kilowatt hour. That is something you need to keep in mind. When is work done by a body said to be negative? So when the force is acting in one direction and the displacement is in the opposite direction, then the work done by the body is said to be negative. So when force on a body and displacement of the body are in opposite directions, then work done is said to be negative. So when is work done positive? When the force on the body, the direction of force on a body, and displacement, direction of the displacement, they are in the same direction, then the work done is positive. Next, what is commercial unit of energy? Yeah, so commercial unit of energy is kilowatt hour. Kilowatt hour is the commercial unit of energy. An object of mass 5 kg is thrown vertically upwards with a speed of 10 meter per second. So there is this is 5 kg thrown up the speed of 10 meter per second. So when you're throwing it up, the initial velocity that you have is 10 meter per second. So kinetic energy what is the kinetic energy when it is thrown? We know kinetic energy is equal to half mv squared. At this point, the v is nothing but the u, so half into m into u squared, which is half into mass is 5 and this is 10 square. So this is 500 by 2, which is 250 joules. Now, when it reaches the highest point, the total kinetic energy would be converted to potential energy. So the potential energy, so you have to write that at highest point the total kinetic energy is converted to potential energy according to law of conservation of energy. So now potential energy would be 250 joules. There would be no kinetic energy since at the topmost point the body stops, there is no velocity, and the whole of the energy gets converted into potential energy. So the potential energy would be 250 joules. What would be the maximum height attained by the body? So we know potential energy is equal to mgh. So mgh is equal to 250 joules. So mass is 5 and acceleration due to gravity 10, and the height is what we want to know is equal to 250. So h is equal to 250 by 5 into 10. The height is 5 meter. So I hope you understood all these 15 questions. In case if you have any doubts, you can always